Hello. Now I would like to explain the change request for RTCM and RINEX and NMEA file by broadcasting L1CB signal. In summary, so we would like to require the change a little bit the RTCM, RINEX, and NMEA standardization. The reason why we would like to require this change is a change of the specification of the QGSS. Now, I would like to explain a little bit the summary of the QGSS and its change signal. And then, so I would like to introduce the request to change for the RTCM and RINEX and NMEA. First, so I would like to a little bit myself. So today's request idea is approved by the many Japanese company involving the GNSS business. So in Japan, there are organizations named the QBIC. The QBIC means QGSS Business Innovation Council. In QBIC, there are more than 300 companies participate in this organization. There are 4 groups in QBIC. So I am involving the standardization working group. In standardization working group, so we are now studying a lot of the standardization. So I am the leader of the standardization group, and so with Seiko Epson. So today's change idea is approved by this working group. First, probably you already know the QGSS itself. First, I would like to explain the QGSS overview. There are 3 functional capabilities in QGSS. One is a GPS complementary, and the second one is GNSS augmentation. And the third one is message service. So the third one is original function of the QGSS. So the QGSS covered area is Asia and the Pacific region like this. So the people in this area can use the QGSS function, but unfortunately, only augmentation service covers only in Japan area. But the QGSS helps us to give the very accurate position even in the urban canyon area. So QGSS contributes big for the GNSS business in Japan and Asia area. And this is a QGSS development plan. So as you already know, now the 4 satellites are launched by QGSS. Now in the service is by the 4 satellites. But so the first Mitsubishi satellite will be replaced in this year because of its lifetime. So another QGSS will be launched this year. So from this one, the signal specification will be changed a little bit. And also the 3 satellites will be ready for launch. So now the from number 5 to 7 satellites is now in the development. Now probably from 2023, the 7 satellite constellation service will be start. So as I mentioned, the specification of QGSS will be changed a little bit from R1. R1 means the replacement satellite from first Michibiki. And also the satellite from number 5 to 7, also the specification is be changed as same as first 1R. So the first change is a signal itself. So the interference problem exists in L1 frequently a long time. So to improve this interferential problem, so we should change its signal, avoiding this problem. Now the current satellite signal is L1CA and L1S. But unfortunately, this signal is a big impact for interference level because L1C is limited for the interference of the Bok 1.1. So avoiding this interference, so Michibiki will send another signal in L1CB. The L1CB frequency service in the alternate from 1R. And also regarding L1S, the L1S service will be stopped from satellite 5. This is a big change from the current QGSS satellite. And also regarding the payload limitation. So from satellite 5 to 7, the mounted resource increases for the measurement satellite distance. So unfortunately, the bus limitation of it's a bus limitation of traditional satellite. So that we should decrease the signal frequency. So this is the reason why the L1-2 signal will be stopped from satellite 5. So for this problem, we should consideration of the status of our other countries' satellite. So this is the detail of the L1CB feature. So probably you already know the L1CB is a modulated signal by Bok technique. The superimposition of subcarrier on the L1CA. And L1CB is less interference by the avoiding L1 frequency of the L1. And of course, this L1CB is forward compatibility in user segment in mandatory. And this is that format for sorting in the user segment. So of course, it is necessary to solution for traditional receiver. So there are many receivers in the market, and many receivers don't support L1CB signal. So if this kind of the receiver acquisition L1CB, so probably this receiver considered is a L1CS signal. So in this case, probably the signal is leveled down, and the position error is very big. So that we should consider to avoid this kind of the error. For the solution of that, so the new PRL code is assigned. So now from L1CB signal, the new PRL code are assigned. So for this, by this solution, the traditional receiver cannot measure the L1CB signal because the traditional receiver don't recognize the new PRN code. And also, the separate health information of L1CA and L1CB. So in the health information, so the status of the L1CB signal and L1CA signal and L1CB signal status will be broadcasted. So if the L1CB signal is sent during the L1CB signal sending, the status of L1CA health information is 1. That means not normal. So in this solution is the contribute to prevent to use L1CA for the measurement. So that this is a PRL code table for our new signal. So as I already mentioned, the new PRL code from 203 to 206 are assigned for the QGSS, this one. So the current PRL code 196 is L1CA signal, but for L1CB signal, new PRL code is 203. And it's the same. The 204 and 205 and 206 will be assigned. So this new PRL code broadcasting means the L1CA signal and L1CB signal are exclusively transmitted. So this is detail about health information improvement. So that consists of 1 SB health and 5 LSB health information. The bit location, first bit MSB named L1 health is a target signal is L1CA or L1CB. And so the first bit is regarding L1CA health information. Okay. And so second bit is L2, and the third bit is L5, and the fourth bit is L1C. Okay. And in status, first bit of MSC is 1. This station is L1CA and L1CB, both cannot use. And so the L1CB health is status of L1CB health information is 1. This means the L1CA is available. And if the 5-bit health, the first bit of information of the L1CA health is 1, this means the L1CB is available. In this health information, so the GNSS receiver can recognize which signal is broadcasting. And this is a summary of the QGSS satellite positioning service. Now, as I already mentioned, the satellite from 1R to 7. So the L1CB signal and L1CB signal is a switchable. And regarding L1-2C signal, from satellite 5, this signal is not served. So regarding this kind of the signal specification changed. Now the current GNSS receiver and GNSS software should be updated. First, the function update on the user segment by L1CB. So, of course, the GNSS data format should be improved. And also the firmware of the GNSS receiver is should be updated. And also the software I/O and application function should be also updated. So to update it, so that we should change the GNSS data format. Format will be changed. This change request we would like to ask today. And regarding the GNSS receiver, so the current GNSS receiver cannot decoding L1CB signal. So the probably the GNSS receiver updated or decoding L1CB. And also if the GNSS receiver can get L1CB signal and calculate its measurement, so the GNSS receiver should output the status of the measurement for the RTCM and NMEA and RINEX. And also the update control command. The control command should be updated. And regarding the software and the application, it's the same. The GNSS data input and output should be changed, and the data transforming should be also changed. So now I will explain the change request for the RINEX. So we should require 5 points for the RINEX change. First one is L1 L1CB description and new PR code add to the RINEX. So there is a satellite ID table in RINEX. So we would like to send a change request, add the new PRN code to this satellite ID table. And the second one, L1CB observation code added in L1 frequency. So, of course, there is no description in the RINEX regarding the QGSS. So the L1CB description is added is a L1 single observation code. And also, in header description, the new QGSS added e-channel attribute in header description. And also, the L1B is described in the reference signal information. And at last, the new PRN code added in the satellite ID mapping table in RINEX. This is summary of the change request for RINEX. And next, the change request for RTCM. The point of the change request is the same as the RINEX. So in RINEX, also, we would like to require or change, required to add the new PRN code from 203 to 206. New signal ID is assigned for the L1CB. And also, regarding FMS data information, so if the L1CB signal start to broadcasting, the FMS data information will be changed. So that's why the L1CB information should be added in the FMS data. And the last one, the ID number for PNL map should be changed. This is also the new PNL code should be added. And the last one is change request for the NMEA. So the satellite ID covered range should be changed. So the this range should be expanded to the PRL of the L1CB and L6E. And the reserved range should be changed in signal channel. Also, the new signal ID should be assigned for L1CB. And last one, the PRN code and the satellite map should be added. New satellite B should be assigned for new PRN code and added the description for L1CB. Okay, that's it. The change request for the RTCM, RINEX, and the NMEA file. Thank you very much.